All right, guys. So we're going to pick up with our graph theory unit, and we're actually going to look at some actual graph theory. So we have this man, Georgy Voronoi, who was a mathematician in Ukraine who invented this thing we now refer to as a Voronoi diagram. There are actually lots of practical applications with Voronoi diagrams with disease outbreaks, which is pretty relevant right now that we're going to touch on later on in the unit. But for now, we really have to understand what a Voronoi diagram is, what it's used for, and how we can construct it. So today's lesson is just an introduction to the Voronoi diagram. Well, I think one of the easiest ways to introduce Voronoi diagrams is to look at a map. And in this case, we're going to look at the map of the United States. So this is the United States, that's where I'm from. And if you take a look at the color diagram, that is a typical map of the United States. But have you ever considered how the borders were drawn? Well, there's a lot of history behind the borders for each state. A lot of it has to do with politics and voting. However, there's another way that we can partition or divide this map. We can actually create or construct a Voronoi diagram. So how could we change this map to mimic what is called a Voronoi diagram? Well, I have a new map that I've created for you that is actually a Voronoi diagram. So let's take a look at that on the next page. So, did you notice how the map changed? So go back and examine the differences here. So suppose that we wanted to create a new map where we divide the United States into regions such that each state's border only contains the points that are closest to its capital than to any other state's capital. So for example, let's take a look at Oklahoma. Oklahoma is actually where I was born, so it's right over here. So this polygon that is in brown here that contains most of the state of Oklahoma contains all of the points that are closest to the capital of Oklahoma than to any other state capital. So a city up here or a city over here or a city down here, those are all points that are closest to Tulsa, Oklahoma, the capital of Oklahoma, than to any other state capital, which is really interesting because as we get into this region here, we're looking at Texas, but there are points within the state of Texas that are actually closer to Oklahoma's state capital than they are to Texas's state capital. So a Voronoi diagram creates these regions that contain points that are closest to a specific point called a site. Okay? So let that marinate for a moment. Go back and rewatch what I just said and let that sink in. We've now created a map where all of these regions are closest to one particular state capital than they are to any other capital. So I'm going to talk a little bit more about that to clarify some things on the next slide. Oh, sorry. I just needed to scroll to the bottom here. All right, so let's take a look at Chicago. So on the left side, I have the original map, which contains Chicago, Illinois. Well, Chicago is in Illinois at present. But if we were to create this Voronoi diagram, where would we actually place Chicago? Well, Chicago, Illinois would now be moved to Wisconsin. It would be Chicago, Wisconsin, because actually Chicago is closer to Madison, the capital of Wisconsin, than it is to the capital of Illinois, which is Springfield, right? So Chicago is in Illinois, and Illinois' capital is Springfield. But Chicago isn't actually that close to Springfield. It's closer to Madison, Wisconsin, which is another state. So again, that Voronoi diagram, the purpose is to create these regions that contain all of the points that are closest to a specific point. And we'll talk about these points here on these edges and the vertices as well. Where do you think those points, where are those closest to? So for example, a point along that edge, is that closer to this state's capital or is it closer to this state's capital? Think about that for a moment. All right, before I answer that question, let's take a look at the definition of a Voronoi diagram. So it's a way of partitioning. Partitioning means dividing a plane into regions called cells. So vocabulary is important. So all those regions that we created, those are called cells, based on distance to a specific set of points, or a point called a site or a seed. We're going to call them sites. So every cell contains a site, and the points within the cell are closer to that site than to any other site in the diagram, right? So it's about saying, I want to create these regions that are closer to one point than they are to any other point. Another way to say it is a Voronoi diagram is a region of influence around each of the given set of sites. So in the United States map, the state capitals are the sites and the states are the cells, right? And we created these new states by redefining their borders so that we had all the points that were closest to a particular state capital. So it says here, you might want to stop the video and read this, these couple paragraphs here about the specific terminology that I just discussed, so sites and cells. It also discusses edges and vertices, which I talked about earlier that I'm now going back to. So let's skip over to that part. It says the lines which separate the cells are called edges. Each point on an edge is equally closest to the two sites whose cells are adjacent to that edge. For example, any point which lies on the blue edge is equally closest to sites B and C. So that's important. If we're within the cell, then those points within the cell are closest to that site. So all the points here are closest to site C than to any other site. However, if we go along the edge of the cell, well, those points are equally close to the two adjacent sites. So here, the two black dots are equally close to site C and site B. So what about the vertices here? So remember vertices, we talked about that when we were defining terms in our geometry unit. So the points at which the edges meet are called vertices, and each vertex is equally closest to the sites whose cells meet at that vertex. So for example, the red, so it says, for example, the red vertex is closest to sites C, D, and E. So let me go ahead and erase that so you can see. Let's erase this region here. Okay, so they're talking about this. So that vertex is equally as close to C as it is to E and D. Okay, so not too difficult. So give this video a pause and go ahead and try example 1 on your own. All right, so we've got a Voronoi diagram here, and they have sites A, B, and C, and it wants to know how many cells the diagram contains. Well, it's pretty easy to count. We've got 1, 2, 3, 4 sites, so we should have 4 cells. So here's a cell, here's a cell, here's a cell, and here's a cell. So we have 4 of them. Now, how many vertices does the diagram contain? So we're going to go ahead and count all of the vertices where those edges meet. So I've got a vertex here, here, and here. So all along the triangle, right? So there are 3 of those. Identify the sites closest to 2, -3. So let's look at 2, -3. So in red here, let's find the point 2, negative 3. So 1, 2, 3. Well, that's going to be closest to B. And let's look at 1, 5. So 1, 5, that's going to be closest to A. And then let's look at negative 1, negative 2. So negative 1, negative 2. Well, that's actually on the edge. Remember that those points that are on the edge of your cells, well, those are going to be equally close to the two adjacent sites. So the two adjacent sites are going to be D and C. So it's equally closest to C as it is to D. And then what can we say about the points which lie on the green edge? So this green edge here. So pause the video if you haven't already done so and answer this question. All right. Well, the conclusion is that the points that lie along that green edge are equally close to site A as they are to B. So they're equally close to A as they are to B. So equally close to sites A as B. All right, so I hope that wasn't too hard. This section and this unit will get very, very interesting. So I hope that I'm sort of selling you on this, and the more that we do and the more practical applications that we explore, the more interested you become with these applications. And as we start thinking about our IA in a few weeks, perhaps this is something that you want to explore. So as far as homework for today, please make sure that you do the associated homework for the Intro to Voronoi diagrams. I will place the homework and keys on OneNote if I haven't already done so. And then for previous homework, please make sure that you have completed the SAT geometry prep worksheet as well as the perpendicular bisectors worksheet. And then of course, check the keys. I have keys for both of those worksheets on OneNote, and I will be doing a homework check at the end of the week. I know some of you guys had questions on some of the SAT problems, so I will try and do a video later on, maybe this weekend, discussing the solutions to that worksheet. I hope you guys are having a great day, and as always, please reach out to me if you have any questions.